Hi guys, what's the square root of 3x plus 1 times the square root of 3x plus 1? It's like me asking you, like, what's the square root of 5 times the square root of 5? And I hope you guys are like, oh, it would just be 5. And so therefore, I hope you guys would say to me, oh, it's just 3x plus 1. And the reason why that is true is because the square root of 5 times the square root of 5 is the square root of 25, which is equal to 5. This right over here, the square root of 3x plus 1 times the square root of 3x plus 1 is equal to the square root of 3x plus 1 squared, which is just equal to, which is just equal to 3x plus 1. That is all it is. And going back to this guy right over here, if you do the square root of 5 times the square root of 5, it's the square root of 5 squared, which is just equal to 5, because to undo something squared, we take the square root. To undo something square rooted, we square it. So therefore, anything times itself in that radical automatically comes on out. Now there's a reason why I'm saying this, because you know me, I like to take things up a notch. So let's go ahead and let's begin and start with, say, f of x is equal to the square root of x. There's something on here. Okay. Are there any restrictions on this domain? Are there any values of x that are going to give us a hard time? And that's the first question you want to ask yourself. When we start doing functions, you guys have to be analyzers because you are in the process of becoming BAMs, and we all know what BAMs are. So, is there anything in here for x that's going to be like, nah, I'm going to give you a problem? And if you said, well, it can't be negative because you can't have a negative inside the square root, you're 100% correct. So your domain is going to be all real numbers where x has to be greater than or equal to 0. Because 0 can be in there, because if I said what's the square root of 0, it would be 0. So now, no matter what I plug in here for x, my y value is always going to be positive. And if you were to do a table of values, because anytime you're like, I'm not sure what something looks like, you could always make a table of values. So let's say we do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth, okay? The square root of 0 is 0. The square root of 1 is just going to be 1. The square root of 2 is just the square root of 2. The square root of 3, this will be the square root of 4, which is, correct, it is 2. This will be the square root of 5. This is going to be the square root of 6. This will be the square root of 7. This will be the square root of 8, which I do want you to simplify. Square root of 8, remember, factors of 8. Pick the pair that contains a perfect square, so you can do the square root of 4 times the square root of 2. So this becomes a 2, so therefore this is 2 root 2. And the square root of 9 is equal to 3. So when you go to graph this, you're starting at 0 and then 1. And then the square root of 2 is just a little bit, this is about 1.4. This is about 1.7. So in other words, those y values are kind of taking their time growing, okay? They're taking their time growing. 4 is 2 and so forth. And the square root of 5, I think, is like 2.2 or something like that. So it's just taking its time growing. So it's almost like you took a parabola and then turn it sideways. Okay, so it has that, because if you look at a parabola goes up like that. But if you kind of turn it sideways, that's what the square root function is going to look like. Okay, so now I want to find the slope between any 2 points on this curve. Okay, so my goal is to find the slope between any 2 points on this curve. So now when I do that, I'm going to do my f of x plus h, which is equal to the square root of x plus h. So now when I go ahead and get my general slope, okay, the general slope is going to be the square root of x plus h minus the square root of x all over h. Now you got some crazy, crazy, crazy stuff going on right in here. What the hell is this, okay? So I'm going to introduce you to something new, and it's called a conjugate, all right? It's going to be called a conjugate. And I'm going to put this off to the side now, all right? And we're going to talk about what a conjugate is, all right? So here's a conjugate. They are opposites, okay? You're going to want to get a notebook and stuff. They are opposites. So let's go back to something like, let's say we had x plus 4 times x minus 4. And let's say if we multiplied this out, and we FOILed it, we would have x times x, we would have x squared, we would have a minus 4x, we would have plus a 4x, and then minus a 16. And if you notice, these two characters are going to cancel, so you just wind up with an x squared minus a 16. Okay? If you did the same thing, if it was like a plus 3 times a minus 3. Again, if you multiply this out, you have a squared, and then outer would be minus 3a plus 3a minus 9. These two cancel, and you wind out with a squared minus 9. So these are considered conjugates. One's positive and one is negative. So if you had something, for example, let's get a little kookadookle, okay? X squared, say the square root of x plus 5 times the square root of x minus 5. Remember, they have to be exact opposites of one another, where this is a plus and this is a minus. That's what a conjugate is, okay? So it's like an a plus b and then an a minus b. Those are considered conjugates of one another. Whoops, you got that cut off there. So conjugates where one is positive and one is negative, like this. And the purpose is, if you notice, if I multiply this out, the square root of x times the square root of x, I hope you guys all realize you're like, oh, that's just x. Yes, it is. And then if you multiply these two, you get negative 5 root x. You multiply the two enters, you get plus 5 root x, and then you get minus a 25. Now, what's interesting is these are exact opposites of each other, so it just cancels out. So when you multiply conjugates, what you should always know, and when you're doing your FOIL, right, the FOIL, the OIs will always cancel out. So it's almost as if all you really need to do is multiply your first terms and your last terms, because you know your two inner terms are going to cancel out. So before I go on, let's do something really crazy. So if I said to you, what is the conjugate of if I did the square root of x plus 3 minus 4 times the square root of x plus 3? This one should be, I hope you said it, plus 4. Very good. So when I multiply these out, because we'll do a couple more, this times this, right? The square root of x plus 3 times the square root of x plus 3 should be, or you know what? Why don't you guys hit pause and multiply this out, and then when you hit play again, you can see if you got what I got, okay? So if we do that, go ahead and hit pause. Welcome back. So you should have x plus 3, and this are going to cancel, so I should have minus 16, so I should have x minus 13 as my final answer, okay? Now, let's say you have the square root of 2x plus 1 plus radical x, okay, times, and what would be the conjugate of that? What would be the conjugate of that? You guys tell me. Okay, yes, you're correct. The square root of 2x plus 1 minus the square root of x. That's what conjugates are. They are exact opposites. And again, the goal of it is to make sure that your middle terms actually cancel, okay? So when I do this times this, I just get, oh, you know what? Hit pause again, my friends. So when I do this times this, I'm just going to get 2x plus 1. If I do this times this, I'll even do it out. You get the square root of x times the square root of 2x plus 1 plus the square root of x times the square root of 2x plus 1 minus x. These two are the exact opposites of each other, which is why they cancel, and you wind up with 2x plus 1 minus x, which is just equal to x plus 1. Okay? So now that we know what a conjugate is, okay, again, they're going to be exact opposites of each other, let's go back to the problem that I originally started with, okay, which was wanting to find the general slope. Let's go back to this guy. The general slope between any 2 points on, I have such OCD, between any 2 points on this square root function, which looks like you basically rotated, or you flipped actually over the line y equals x, that guy right there. So now we found out what f of x plus h was equal to. So now if I want to get the general slope, right, I'm going to multiply this by, you got it, I'm going to multiply it by the conjugate. So the conjugate of the square root of x plus h minus x would be the square root of x plus h plus the square root of x, but I also have to multiply the denominator by, you get it, the same thing, because it's the same thing as multiplying it by, you got it, 1. By multiplying it by 1. So this is just another fancy form of 1. Now, at this time, you should all be screaming, uh-oh, Schwa, we got to put parentheses around stuff. Well, you're goddamn right we do. So we're going to put parentheses here, and parentheses here, okay? So you have to put your parentheses in there, otherwise the schwatz is going to hit the fan, okay? All right, so again, our general slope, my friends, is equal to. So if I were to do this like we did, distribution, so why don't you hit pause and see if you can come up with what I come up with, okay? Welcome back. So I have the square root of x plus h times the square root of x plus h is simply x plus h. Again, this term, the outer term and the middle term are going to cancel because one's positive and one is negative, which is the whole point of multiplying by a conjugate. And then square root of x times the square root of x is minus an x. And then downstairs, we don't do anything. We just leave everything as we see it, okay? All right, we never do anything to the denominator. So now if I look up at the numerator, okay, so now if I look up at the numerator, I just look at myself. Remember, you never stop. Ooh, the x's cancel. I'm left with an h, and then I have an h downstairs. So this is going to be x plus h plus the square root of x downstairs. So again, your h's cancel, which is delightful because it's h times that entire quantity. So therefore, there are no plus signs in between. This is technically one big giant term down here, which is why I can make that a 1 and I can make that a 1. So now the general slope is going to be 1 over the square root of x plus h plus the square root of x. And that is equal to the general slope for f of x is equal to the square root of x. Okay, so if I want to find the slope between any 2 points on this curve, I can go ahead and do that. And we'll probably do that on Tuesday. So I'm going to do another problem with you like this. And I'm obviously going to make this parent graph because this is the parent graph. When I start adding terms and doing kookadookle things with it, we'll see what we can do from there. Okay, but this is the start.